Salt facts. In chemistry, a salt is a solid chemical compound consisting of an ionic assembly of cations and anions. Salts are composed of related numbers of cations and anions so that the product is electrically neutral. These component ions can be inorganic, such as chloride, or organic, such as acetate, and can be monatomic, such as fluoride, or polyatomic, such as sulfate. Types of salts. Salts can be classified in a variety of ways. Salts that produce hydroxide ions when dissolved in water are called alkali salts. Salts that produce acidic solutions are acid salts. Neutral salts are those salts that are neither acidic nor basic. Zwitterions contain an anionic and a cationic centers in the same molecule, but are not considered to be salts. Examples of zwitterions include amino acids, many metabolites, peptides, and proteins. Properties. Color. Solid salts tend to be transparent as illustrated by sodium chloride. In many cases, the apparent opacity or transparency are only related to the difference in size of the individual monocrystals. Since light reflects from the grain boundaries, larger crystals tend to be transparent, while the polycrystalline aggregates look like white powders. Salts exist in many different colors, which arise either from the anions or cations. For example, sodium chromate is yellow by virtue of the chromate ion. Potassium dichromate is orange by virtue of the dichromate ion. Cobalt nitrate is red owing to the chromophore of hydrated cobalt 6,2+. Copper sulfate is blue because of the copper chromophore. Potassium permanganate has the violet color of permanganate anion. Nickel chloride is typically green of. Sodium chloride, magnesium sulfate heptahydrate are colorless or white because the constituent cations and anions do not absorb in the visible part of the spectrum. Few minerals are salts because they would be solubilized by water. Similarly, inorganic pigments tend not to be salts, because insolubility is required for fastness. Some organic dyes are salts, but they are virtually insoluble in water. Taste. Different salts can elicit all 5 basic tastes, for example, salty, sweet, sour, bitter, and umami or savory. Odor. Salts of strong acids and strong bases are non-volatile and often odorless, whereas salts of either weak acids or weak bases may smell like the conjugate acid and cyanides like hydrogen cyanide or the conjugate base of the component ions. That slow, partial decomposition is usually accelerated by the presence of water, since hydrolysis is the other half of the reversible reaction equation of formation of weak salts. Solubility. Many ionic compounds exhibit significant solubility in water or other polar solvents. Unlike molecular compounds, salts dissociate in solution into anionic and cationic components. The lattice energy, the cohesive forces between these ions within a solid, determines the solubility. The solubility is dependent on how well each ion interacts with the solvent, so certain patterns become apparent. For example, salts of sodium, potassium and ammonium are usually soluble in water. Notable exceptions include ammonium hexachloroplatinate and potassium cobaltinate.